vectors have both magnitude and direction. Magnitude means length. We've looked at vectors before when we were looking at translations. Do you remember? That they're written like this. And this told us the horizontal movement and this told us the vertical movement. Do you remember that? So that's what a vector is. They're written as letters, either in bold or underlined. So we would label this as A, bold A, or it would be A with an underlining or a squiggle. Okay, so that's how you would recognise it as a vector. It's not made to be important, exciting information. So we use these when translating shapes. So 4, -3, so as it says here, the top number shows the movement right or left. Which way do you think you go if it's a positive number? Yeah, right, and obviously if it's negative, you're going to go left. And the bottom number, which way would you think you would go if it was positive? Up. Yeah. And then negative would be down. Yeah, makes sense. So if we were trying to show the vector for 3, it means that we're moving right 4 and down 3. So for example, this is going to be really awful. If this was our starting point, okay, then from that point I would go across 4, 1, 2, 3, 4, and down 3, 1, 2, 3. So I would finish up there. And so my vector would be shown with a line going from the start to the finish, and we would have an arrow on it. Now yours is going to look much prettier than that. Obviously it's painstakingly hard to do on these things. Okay, bless you. But does that make sense? Yeah?
Will it tell us where our starting point is?
In general, yes, but if not, you can just do it anywhere. Now, notice I had a look at my vector before I drew this because I could see it was going to go down, so I started it higher. Obviously, if you had a positive value on the bottom, you probably have your starting point down here. Yeah, so just think sensibly when you're drawing that. So vectors are equal if they have the same magnitude and direction. Okay, so this here, this is A, it starts here and goes here. I know that because my arrow is pointing down. This one starts here and ends here. So these are not equal to each other. Okay, so A is not the same as B because they have a different direction. They have the same magnitude, so they're the same length as each other, but they have a different direction, therefore they are not equal to each other. Okay? Oh, pretty self-explanatory. Yeah? So, identify the following vectors. So, we're going to write all of these vectors in column format. So, we're going to have a little column next to it. So, you can see which way the arrow is going, hopefully, even on yours. Yes, you can see the baby arrow. So, this one started here. What's my horizontal movement? Positive or negative what? Positive 2, good. So that's the 2 on the top. And then what's my vertical movement? Positive or negative? Positive. So that would be the vector 2, 5. Cinchy? Yeah? So you do the other 3. Alright, okay. So what was green and yellow? What's this one? 3, -5. I'm trusting you, not if you shout no, then I'm down with it. Dinah, what's the next one?
4, 0.
I'm jumping. And the next one, Lena? 6, 3. Okay, hopefully we'll... No, 6, 3. The horizontal is 6. Alright, now you need to draw the following vectors. So as I said before, think about where you can start them. So have a little look, see, are you going to the left, are you going to the right? Are you going up or down? And that will help decide where you're going to start them. So if I do this first one with you, I know I'm going to the right 5 and I'm going down 2. So I'm going to start mine here. I'm going to go to the right 5, so 1, 2, 3, 4, 5, and down 2. And put an arrow in it. Your arrow would normally go in the middle. Obviously, the drawing feature only allows you to put it at the end. Okay, so that's the first one. You're going to do the other 2. So hopefully you drew something kind of like this for this one. And this for this one.
Yeah, like the last one, I think.
Oh, okay, we can sort that out then. Right, adding vectors. Adding vectors, really cinchy. If I was adding a vector on a diagram, all it would mean is that you would draw one vector. So you would say, for example, we're adding A and B. We would draw vector A, which we've got here. And then we would draw vector B at the end of that. And then this, the movement from the start to the finish, would be my answer, the result. Okay? So if you were, as I said, if you're doing it diagrammatically, you would just draw it and see where you ended up and how would you describe from this point to this point. The order that you add them doesn't matter. So here we've got B first and then A. You can see that you end up at the same point, at the same finish point. So that's on a diagram. If you would go in the opposite direction, so if we were trying to say we were starting at X, so this X here, and going to Y, we would be going along A in a positive direction and along B in a positive direction. You can all see that? Yeah, so from X to Y, which is what this is indicating, we're going along A in a positive direction and along B in a positive direction. If we were going from Y to X, so note that order is important, we're actually going the opposite direction of B, so that's why we would have negative B, and we're going the opposite direction of A, and that's why it's negative A. That all makes sense? Like it's not crazy maths. We can just see, are we going in the correct direction, is it plus, or the opposite direction, in which case it would be minus.
But for me, why would it be positive with first camera and coming down?
Because B was in that direction.
We're not going to be good. Oh.
B already had an arrow in that direction. So if you're going up on the opposite direction of this arrow, then it would be negative. Okay? It's really in my head. As it says, we take a long time if you're drawing all of them. You sometimes have to draw them, but very rarely. Generally, we're just using simple arithmetic. So if you were trying to find vector P, they said the vector P is equal to A plus B. So we just look at A and B. So we would say P, underline it, is equal to 4, 1, plus negative 3, 5. That's pretty cinchy.
That's it.
Well, no. And then we just add those numbers. So P. But you would add the horizontal movement numbers. So what's 4 plus negative 3?
4.
And then we'd add the vertical movement. So 1 plus 5. 6. So that's vector P.
Well, that's it.
So I did a P with an underline. Underlined it. That's it.
What if you don't know what A?
You'll be told it.
Okay.
Or you'll be told the answer and you can work it out.
And you're not going to give it, you give it just B and you have to figure A and B out.
No, you'd have enough you don't need this in one thing. Or enough information. You'd have enough information to find what you're missing. Really?
So, like, can you explain it again? It's like, I get it, but, so you don't have to draw the
So you don't have to draw them because if you're so in a way what this is doing here is working out your movement without actually drawing it.
So it's like going
Because
up
if
and
you're
down.
starting at any position, if you're going right 4
Yeah.
and then back 3, you've ended up moving right 1.
Oh, okay.
Yeah?
Yeah.
And if you had gone up 1 and then up another 5 from that point, you'd have gone up a total of 6.
Oh, I see.
So it's literally just simple arithmetic. But you just need to join your horizontal movements and your vertical movements. Magnitude, as I said, magnitude talks about length. And for any vector, we can see that we can form a right angle triangle, can't we? Yes? So if this vector, for example, was the vector 2, 5, okay? So if this is the vector 2, 5, we would find the magnitude of it by saying 2 squared plus 5 squared. Now, the magnitudes are always going to be plus, okay? The reason being is that our vector will always be our hypotenuse. So you don't have to worry always if you can add or subtract, am I finding the long side or one of the short sides? They're always going to be addition, because it's always going to be the hypotenuse. So this one would be 4 plus 25, so that's root 29. So the magnitude of P would be the square root of 29. Now we normally show magnitude by the two vertical lines either side. Okay, yeah, the P is my vector, so that's why it's underlined, and then the magnitude is shown with the modulus signs. Okay, we're getting into fancy terminology, but it's just essentially multiplication. So a scalar means that you are scaling it up, essentially, and you're making it bigger or smaller depending on your original one. So if this was vector D, then this vector 2D, the number 2 is what we call the scalar. Okay, so we've just made it 2 times bigger. This one, what's different about this one compared to this one? Other than the fact that the 3 and 2. And so what has that done to my vector?
Made it the vector is
Lovely, so it's changed the direction. Lovely, okay, all so far so good. If vectors can be written as a scalar, they would be parallel to each other. So for example, if what's that got to do with that? Why don't I put that there? If I had oh, that's annoying. If I had A was 4 oh, I'll use A there. If P was 4A plus 6B and Q was A plus 2A plus 3B, then I would know that these two were parallel. The reason being is that I could bring a factor of 2 out here, and I would be left with 2A plus 3B. Yeah, I'm going to do the magnitude of it like down here. Do I talk about anything else? Yeah, no. Why am I doing that fancy there? That's really annoying. So, who said I did? Do we know what's going on here? So I said, if vectors can be written as a scalar, they would be parallel. So I would say that P is parallel to Q because I can do this.
Do we have to do the stupid underline thing?
You should do, yeah. Right, why are we doing this? So a question might say, is vector P parallel to vector Q? And so you're looking at this going, I don't know. So what you have to do is you say to yourself, okay, is there a way of writing this vector here in terms of this vector? So if there is a chance that you can do that, then it means that they would be parallel. So because vector P can be written as 2Q, okay, so vector P is the same as 2 lots of Q, because I was able to factorize it, it means that they are parallel. Is everyone clear on that? It wasn't excellently explained. But do we understand? Yes? Is that you happy now?
Yeah.
Okay. Now, it's not always going to be a nice number like 2. It could be like 1.5 or 1.2. But essentially, you need to see, can you do anything with this one to get it in terms of this one? Okay, so are you able to multiply both of these two numbers here by the same thing to get to this one? Okay. If R was this, it's got 3 terms in it. Okay. Now the magnitude for 3 terms would be worked out in a very similar way. You would just work out 3 squared plus 2 squared plus 1 squared. No, we've got what? Shut up, Miss Harrison. We need to find the vector first, you fool. We don't know what A, B, and C are. This is just in some random place. Get rid of this. I rewrote these notes. Where did I get that from? Maybe we've got A, B, and C somewhere else.
Yes, we do. We have A, B, and C here.
Oh, shush now. Oh, well, then I'll do it then. And the bus out. Don't worry, don't worry. So diagrams may be used in questions. Sometimes that means you need to remember some geometry rules. A, B, C, D, E, F is a regular hexagon. What does this word regular mean?
All the lengths are equal.
All the lengths are equal. Okay? So all of the side lengths are the same. So this and this and this and this and this, they're all the same length. Okay? Has a center O, A, B. So going from big letter A to big letter B, they've called the vector X. And from big letter B to big letter C, they've called the vector Y. Okay, so this is the information that we know. Not looking at this just yet, if this is the vector Y, how can I describe this vector? DNA? Y, yes. That would also be Y. Because it has the same length and it's going in the same direction. Does that make sense? So, no, I said this is Y.
Yeah.
X goes that way.
And then the other one.
So if we were to find another vector that is the same or equivalent to this one, who can tell me 2 letters of a vector that will be the same as X? Any 2 letters?
Can you say that?
So tell me, so we said that AO would be the same as this one. Tell me one that would be the same as vector X. Brianna? Pardon?
O and F.
Be careful. So those 2 letters are fine, but tell me in them in the correct order. Because this vector starts here and ends up here. So your vector, equivalent vector would have to be FO. Do you see the difference? No. Whilst this length is exactly the same, you told me OF, so you started here and ended up here.
Yeah.
Whereas this one starts this side and ends up this side. So you must make sure you're telling me FO. It's like that very first page of the sheet where I've said that about A and B, and they are not equal to each other because they're different directions. So you need to make sure you're telling me in the same direction. Have I said it any better? Does anyone else help me? Like, for example, ED would be equivalent.
Yes.
OC would be equivalent.
Equivalent to X.
Equivalent to X, yes?
Yeah.
Because they all start left and turn right. Yours started right and turned left. Am I not saying it very well?
You are. So maybe if you have an arrow now.
So if you told me O to F, which does that?
Yeah.
You see how that's the opposite direction?
Yeah.
So you must, if you're trying to find an equivalent one, you have to say FO.
But why can't I?
because it's the wrong direction. With vectors, normally it wouldn't matter if we were just talking about the length of the line, but for a vector, the direction is really important because it makes it different. Okay? Maybe we do a few more examples. Going back to the actual original question, it says we need to express the vectors e to d, d to e, f to e, ac and fa and ae, of course, loads of them, in terms of x and y. So we're just using the letters x and y. So if we started at e and ended at d, we find e, we end at d. How can I describe that movement? Shayla? So if I started at E and ended at D, is that the same as either X or Y? X. Nice. So I would say that this is equal to X. Does everyone get that?
Yeah.
Next one is DE. Okay, so this time we go in the opposite direction. So Brianna, I'm now starting at D and ending at E. How can I describe that movement?
Y.
From D to E. So D to E. Y goes in that direction. So what's this similar to?
So none of them?
No, it is. It's in terms of we could use it one of those to help us describe it.
Oh.
3.
Could you just say that it's not equal to x, like the line through the equal sign?
But what's different about so if E to D was X, what would D to E be?
Would it be negative x?
Negative X. Brianna, are you okay with that? Because it's going the opposite direction. So you know when you told me OF, that would also be negative X because it's the opposite direction. We're going way into our 20s here. FE. Next. FE. So F to, oh, shush now. F to E. Jamie?
Y.
Is Y, correct? Yes?
Y is 1.
Huh?
Where?
Are you talking about the next one?
Oh,
Yeah.
yeah.
Oh, hang on. Well, hang on.
Why doesn't it go this way?
Why doesn't what go what way?
The D to E, the little, what's it called at the top?
The arrow?
Yeah.
Because it's, well, they want to start at D and finish at E.
But it goes
Look at the question, darling.
Yeah. Okay.
No? Am I misunderstanding?
Okay. Yeah.
So from D to E, I started here and ended up here. So that's the opposite direction to this one.
But it's going this way.
So it's going this way, yes. Yeah? So if it was equivalent to this, we would start here and end up here. Yes? So that would be X. But if we've started here and ended up here, that means it's negative X because it's going the opposite direction.
Yeah. Okay.
Oh, I don't know what.
It's okay. It's not important.
What it is if you don't understand?
It's just the way the question was written.
Okay, A to C. It's a bit more challenging. So we're starting here and we're finishing here. What journey can I travel? Now, I can't cut through the middle. I have to follow the paths of the lines. You're not allowed to just cut through the middle. So how can I get from part A, from letter A, and finish at letter C, diner. Which path do you think I can travel it?
I would like from F.
So from A to C, how can I get there?
Through B.
Through B. Okay, so if I traveled this direction, which vectors have I traveled through?
X and Y.
And what am I doing? Are they in the correct direction for X and Y? So that means it would be X plus Y. Yeah. So we've got X plus Y. Do we all follow that?
Yeah.
So you have to follow the correct direction. Now, admittedly, from A to C, I could have also gone down here and up to here. Agreed? So I would have travelled along here, which we know is equivalent to Y, and then this is equivalent to X, so it would have been Y plus X. Okay? Same, different grading. I could have also gone down, oh no, we don't know that one, so shut up. F to A. F to A. So we're going F to A. Just two people in a row? Kiara.
You go X to O, which is X,
Nice.
and then O to A, which is negative Y. So plus. No, take away.
Nice. Awesome. Are people happy with that?
No.
So we started at F,
I don't know.
and we've gone this direction to O. And so that is X. And then we had to get to A, so we went the opposite direction to this one, which would have been negative Y. So X take away Y. Alright, okay, so
It's not a 3D cube?
no, it's just a hexagon.
It looks like a 3D cube.
It's a hexagon.
Yes,
Alright, okay, shh. I'm gonna have to do it back here because the boards really annoy me. Now, shh. Okay, if we want to try and describe something, we have to follow paths of vectors that we know. We are only knowing that this direction here is X, and we know this movement here is Y. That's all we know. So Gabrielle, we cannot just go up to that because we don't know how to describe that movement. So we have to instead follow this path and then this path, because we only know how to describe those vectors. Excuse me. So if I labeled this movement here as X, this would be X, this would be X, and this would be X. You all happy with that? If this was Y, then this is also Y, this is also Y, and this is also Y. They are the only moves that we can use in this question. Now obviously we can go the opposite direction to them, so they would be negative versions of them, but they're the only moves that we can use. So to get from F to A, we have to follow those paths. Now you could have gone all the way around the houses. You could have gone all the way up here, back along here, and back along here. But if you'd done that, it would be X plus X. Let's write it. X plus X minus Y minus X. You all agree with that? So had I gone all this way, I could have done that. But look what happens here. I've got X plus X minus Y minus. So this X, take away this X, has disappeared. And so you end up with just the same as we had before. Is everyone understanding what we need to do? You have to follow those paths. So if we then had our final one is AE. So again, we need to follow these paths.
So how can we start at A and end up at E, only following the blue or red lines? Casey, can you do that one for me?
A to O, O to F, F to E.
Oh, okay. So what's A to O?
Y.
And then O to F?
Negative X.
And F to E? So what would I write?
Positive.
Yep. And then we would join like terms like we would do normally. So we've got a Y plus another Y. So that would be 2Y take away X. You happy with that?
Yeah.
Now, see, that's funny that Casey did that, because I would have probably gone all this way and then done that. But you get the same answer. Y plus Y minus X. 2Y minus X. Okay, so it doesn't matter how you do it. You always end up, once you've simplified it, with the same answer. Okay?